Bojo, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or through the television at Bell Express View channel 972. You can always join me through Zoom live. The link is available through me, your teacher, or also through your DEC. Our classes are scheduled on Monday through Thursday from 11 till 12 in the morning. And we are currently in our third week of our 9-week course. A reminder what work to submit for marking. The support questions, those marked with the pencil icon, are not to be submitted for marking. You decide which ones to do and how many of them to do. They're just practice for yourself. If you're understanding the concept, feel free to skip them. But if you need more practice, let me know and I can send you more. The answers are in the back of the booklet, so check your work to make sure you're on the right track. However, many mistakes have already been found. So if something doesn't seem to be lining up, let me know and I can tell you if that's a mistake in the answers. The key questions marked with a key are the questions to submit for marking. Please do all of them and show all of your work, your steps and your thinking so that I can understand what your process is and if you're making any errors, where those errors are. How to submit your work for marking. There are 3 methods. The first is to scan your work and send it in electronically. You can scan your completed work through the iPhone's Notes app or through the Android Google Drive app. And then you can send it by email to studentwork@nnecon.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street, where the big red building next to the post office, and there's a small white mailbox next to our side entrance. We are continuing to work remotely, so it may take me a couple days to get your work, but once I get it, I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you have any questions or concerns, please contact me. My email address is bronwyn.slate@nnec.on.ca. That's spelled BRONWYN.SLATE. My Facebook is bslatewahsa, and you can call the main office and leave a message for me there, and I'll return it as soon as I can. The phone number is 807-737-1488. Toll free, it's 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. till 2 p.m. And I'll try to get back to you as soon as I can. Connecting with me through Facebook. Both my Facebook and YouTube are named bslatewahsa, and I post all of our classes replayed videos on YouTube and share them on Facebook. So that's a great way to access the replays if needed. Also, there are short videos that explain common errors and confusing concepts on my YouTube. So that's a good place to start if you're struggling with something and you need some help. Subject. So if you're able to access the replays or to join me live through Zoom, I strongly encourage it. It is incredibly difficult to just listen to me talk and understand what it is that I'm saying. Being able to see placement of things and organization is all part of math as well. So being able to connect to the video is going to set you up for the most success. All right, we're on day 11 of our course in week 3. And today we're looking at lesson 8, which is the compound interest formula. Our learning goals are that at the end of this lesson, you can say, I will be able to solve problems finding the principal in situations when interest is compounded. And 2, I will be able to solve problems where I must find the interest rate and the length of time when interest is compounded. Your success criteria, knowing that you've met your learning goals, because you can say, I can identify the given and missing information in compound interest problems. 2, I can use the nth root and guess and check methods to solve problems involving exponents. And 3, I can solve problems when either the interest rate or time length are missing. All right, let's activate our brain and do some mental math. As we say each day, our mental math, as young people in elementary school, many of us experienced Mad Minute math tasks, and those were not positive experiences and create a lot of anxiety and didn't actually help us learn our math facts. So instead of encouraging those, we look at strategies that we can transfer to different situations and actually build skills opposed to just memorization. So today's question is 45 plus 47, and we're going to use a strategy of near doubles. So what this strategy is that doubles are numbers that often stick in our mind that are easy for us to remember. And so using that information can help us apply to other questions. So 45, in my mind, 47 is really, really close to 45. 47 is 45 plus 2. And I know that 45 doubled, so 45 plus 45 is 90. That's something that sticks in my head. So then if I only need 2 more, so 90 plus 2 is going to be 92. So therefore 45 plus 47 is going to be 92, because just 2 more of 45 doubled. And this you can apply to various situations when you have numbers that are close to each other, that you can make that double that can help you figure it out. It's a really useful strategy. All right, mine's on. Let's engage in some prior learning. Remember what we've been doing. So we have been talking about compound interest, which is the interest that's calculated on the principal and the interest that's already been earned. It has exponential growth. I like to call it free money from free money. And it's really great for investments, but it's not super helpful if you're borrowing money, because it means that the interest that you're owing is increasing as well. So we have this little graph here that reminds us that simple interest is linear. It grows at a constant rate, it grows slower, and compound interest grows at a constant ratio, which means that you're increasing by the same amount, multiplied by the same amount each time. And so you can see that that grows really, really quickly. And over time, they're really far apart. At the beginning, they are the same, but over time, compound interest earns a lot more interest than simple interest does. Our compound interest formula, I use the formula A equal P times 1 plus R over N, all to the exponent NT. This is not what's in your IL booklet, but it's what we've been using. Reminder that A is your in dollars, P is your principal invested, the money you start with in dollars, R is your interest rate expressed as a decimal, N is the number of compounding periods per year, and T is your time in years. Your IL booklet uses A equals P times 1 plus I to the exponent N. We went through our last lesson and how these are the same, but it's just a matter of organizing the information slightly differently. So if this is new to you, go back to that previous lesson, and to look through that, I'll link it in the show notes. Another reminder about compound frequency. So the compounding period means the time frame in which compound interest is calculated. Often compound periods are less than 1 year, and we have various different ways that we can compound. So annually means that we compound once, semi-annually is twice, quarterly is 4 times, monthly is 12 times, weekly is 52 times, and daily is 365 times. So it's important to know those words and their corresponding number, in order to interpret our questions. All right, active learning, let's explore some new concepts. As always, answering the question, when will I use this in real life? So we, in this course, are identifying the information that we have and what we need to find. Though you might not have math questions in your life that show up that you need to find P, and you need to know that you have A and R and N and T, but in life, you will have situations where you have various information and you're trying to solve a problem, and you need to figure out what information you still need and what information is useful that you have in order to solve those problems. And that can be in any sort of situation, whether it's parenting, working, running a business, having relationships, all those sorts of things. You have problems will arise, and having the skill that you can identify the information you have and what information you need is really, really useful. So how is this sort of math around us? The questions that we're going to be looking at today are, how much should I invest to earn a certain amount of money? How long do I need to invest in order to earn a certain amount of money? Or what interest rate will earn me a certain amount of money? So that's a lot about money and investments, which is really good to know. Also, in terms of debt, it's also really good to know because that can get us into tricky situations sometime. All right, so first, we're going to look at finding the principal in compound interest. This is on page 16 of your IL book. So the real life context of this is when you want to find out how much you should invest now in order to earn a certain amount over a set period of time. So if you want to earn $1 million in 20 years, how much do you need to invest now in order to earn that is the context. So our question, a person wants to have $10,000 in 6 years. They can invest at 3% compounded semi-annually. What amount do they have to invest now in order to make this happen? So how do we break up this question to know what we need to do? So first, the question says compounded semi-annually. That means that this is a compounding interest question. So we use our A equals P times 1 plus R over N all to the exponent NT, and we need to find all of our variables. So how I do a question like this is I identify that it's a compound interest question, and I write down my equation and all of my variables so I can figure out what my variables are to organize my information. So going through the question, what do we know and what don't we know? So the person wants to have a $10,000. So that is our A. That is our final amount that we want. So A is going to equal 10,000 in 6 years. So our time is 6. They can invest 3%. So our R is 3%, which is 0.03. It's compounded semi-annually. Semi-annually means that our N is equal to 2. And then what amount do they have to invest now is our principal. So that is what we're looking for. So now that we have all of our parts and we know what we're looking for, we can then substitute our values into our equation and solve it from there. So now substituting our values in, we have 10,000 equals P times 1 plus 0.03 over 2, all to the exponent 2 times 6. So then if we compute what we can, so 10,000 equals P times 1.015, all to the exponent 12. So then rearranging to solve for P, we have 10,000 divided by 1.015 to the exponent 12, which means that P is going to equal $8,363.87. You're going to need to use a scientific calculator because you need to be able to have exponents that you can change. You can choose how much your is squared. It's this example, it's to the exponent 12. So you can use the Desmos scientific calculator or other scientific calculators. I'll link them in the show notes if you need them. So therefore, they should invest $8,363.87 now so they can earn $10,000 in 6 years. There we go. All right, before we can go on to our next example, we need to pause and we need to remember some algebra with exponents. So this is a little bit of a review maybe, but it's useful for what we need to do. So we have two situations. Our first situation we're going to look at is when we have a variable with an exponent and how do we solve for that. So for example, x to the exponent 5 equals 32. So we have to figure out what x equals. So we remember that x to the exponent of 5 means a number times a number times a number times a number times a number to equal that amount. So we have 32 is equal to a number times a number times a number times a number times a number. That same number times itself 5 times is equal to 32. So how we do this on our calculator, so we have x to the 5th equals 32. So what this means is that we have to take the 5th root of 32 in order to cancel off. The fifth root cancels off an exponent of 5. It is the opposite. It's finding what that number is. And so we need to do the fifth root. So that is 2. 2 times 2 times 2 times 2 times 2 equals 32. So x equals 32 in this example. Sorry, x equals 2 in this example. So that x to the fifth equals 32. So generally, the square root is what we are most commonly with. So a square root used 2 times in multiplication gives you your original value, right? The square root of number times the square root of number gives you that number. The cube root is used 3 times in multiplication to give you your original value. So the square root or the cube root of a times cube root of a times cube root of a equals a. And so in general, the nth root used n times in multiplication gives the original value. So the nth root of a times the nth root of a times the nth root of a times the nth root of a. So n of those equals a. So for example, for another example, x to the exponent 3 equals 125 is equal to taking the cube root of x cubed to cancel off those cube. And then we have to take the cube root of 125. So we're going to use our calculator. You're not going to likely to know these I don't know many of them. I know a couple, like maybe 5, but I use my calculator. So the calculator button for the nth root is often the second function of your y to the exponent, your x to the exponent y button. It often looks like a square root with a little x in front of it. It could look like something different, but that's generally what it looks like. So if you remember on your calculator, you found your button where you could have your any exponent number. So you could have your any number to the exponent 100 or exponent 5 or exponent 10. So that button, likely this is your second function. If you're not familiar with your calculator and you're not sure how to find it, let me know and I can help you walk through it. We're just going to look at using the Desmos, how to find it on Desmos. So here on Desmos, it is the nth root is this symbol here. So it looks like a square root, but it has a little n on it. And so our question was, we're looking for the third root of 125. So you need to figure out how you put it in your calculator. So for this Desmos calculator, you put it in, you click your nth root, and then you can see our cursor is up where the n would be. So we're trying to figure out the third root. So we put the 3 there, and then we put 125 underneath the root, and we find that the answer is equal to 5. So you need to figure out how your calculator does it. Some you put in the part that's underneath the root first. Sometimes you put the number in before you press the button. You need to play around with your calculator to figure it out. So x equals 5 in that example. So here we have y to the exponent 8 equals 65,536. I have no idea what that is, so I would put in the 8th root. So on my calculator, I would say, what is the 8th root? And it was 65. Oh, you got to pay attention to my calculator. I put it in the wrong spot. So 65,636 is equal to 4.00076. So basically, oh, it's because I put a number wrong. That's why. 8th root of 65,536. This is not liking me. So you can see your calculators can sometimes be a pain. So that is equal to 4. You're not always going to get a nice friendly number. That's a whole number. So we, example 3, a to the exponent 15 equals 325. So again, we take the 15th root of both sides, and a is equal to 1.4705. Generally, I would give it 4 or 5 decimal points if you're writing it down. If you can keep it in your calculator, great. Often that might not work, but that's how you do it. Okay, so how do we apply that? We're going to look at finding the interest rate, R, in compound interest. This in your IL book on page 16 is the finding the I, and they use guess and check. Because they do I as a, instead of breaking it up into the two parts with the compound and the rate, it's a little bit harder to know exactly. So we're going to use the nth root in order to find what R is, but in your IL book, they do it slightly different with a guess and check, which you can totally still do is fine. So in the real life context, this is when you want to find what interest rate you need to earn a goal amount when you have a set amount to invest now over a set period of time. So you say, I know I have this much to invest, I want this much, what interest rate do I need? So our example, a person wants to have $1,500 after 5 years. They can invest $800 now in an investment that compounds quarterly. What interest rate do they need to make this happen? So we need to dissect our question to figure out what we know and what we don't know. First, the question says compounds quarterly. Therefore, it's a compounding interest question, and we know that we can use A equals P times 1 plus R over N all to the exponent NT. So now we need to figure out what we know. So the question says wants to have $1,500. So that means that A equals 1,500 because that's what we want to have at the end. After 5 years, 5 years is our term, our T. They can invest 800 now. So that's our principal, how much we're starting with. It's compounding quarterly. So N is equal to 4. And what interest rate is what we're looking for. So we're looking for R. We substitute our values into our formula. So we have 1,500 equals 800 times 1 plus R over 4 to the exponent 4 times 5. We're just substituting our values into our formula. Then we simplify what we can. So 1,500 equals 800 times 1 plus R over 4 to the exponent 20. This time we can't simplify as much because that R is what we're looking for. So we're continuing to isolate for R. That's what we're trying to find. So we do 1,500 divided by 800 equals 1 plus R over 4 to the exponent 20. So that's 1.875 equals 1 plus R over 4 to the exponent 20. Now we need to use that nth root, right? We need to take the 20th root in order to isolate for R. Reminder that the square root is the inverse of something squared. So the 20th root is the inverse of x to the 20th. So we take the 20th root of both sides in order to keep ourselves balanced. And so we have 1.0319 is the 20th root of 1.875 is now equal to 1 plus R over 4. And now we can continue our algebra. I've run out of space on my slide, so I've just drawn an arrow. Sometimes that happens, totally fine to just draw an arrow to organize your information. So we have 1.0319 take away 1 equals 1 plus R over 4 take away 1. So we're trying to isolate for R. So 0.0319 is equal to R over 4. So we're going to multiply both sides by 4 in order to cancel off the 4. And we end up with 0.1277 equals R. Our rates we put in a percentage, right? So we're going to times that by 100. So we get 12.8% is our rate. So therefore they need an interest rate of 12.8% in order to earn what they want to earn. And that's how we find the rate. It's a few steps. Lots of it is algebra, which you should be familiar with. If you need help with that, let me know. But the nth root is really what's new for this part. All right, we need to pause again. And we're looking at situation 2 when we have the variable in our exponent. And what do we do with the algebra then? So this is when we have 4 to the exponent n equals 64. So we're wondering how many 4s do we need in order for it to be equal to 64? So we're looking for the n number of 4s. This we need to do with guess and check. We don't have the tool, the mathematical tool to solve this yet. So we have to use guess and check, which is how they do it in your IL book as well. So we're trying to get as close to 64 as we can with a base 4. So 4 to the exponent 1 is equal to 4. 4 to the exponent 2 is equal to 16. 4 to the exponent 3 is equal to 64. Okay, we got what we wanted. using your calculator is completely understandable and fine. So that's fine. You can just put them in and check to see what works. So 4 to the exponent n is equal to 64. So how we write this is that we're trying to get it so that we have the same base so that we can solve for our exponent. So we found out that 64 is equal to 4 to the exponent 3. So we replace 64 with 4 to the exponent 3. So we now have 4n equals 4 to the exponent 3. Because our base is the same, we now can say if our base is the same, that means our exponents have to be the same. So n is equal to 3. So our first step to break it down is that we use the guess and check to make the bases on both sides of the equation the same. And step 2 is then the exponents are equal to each other. And then we can figure it out from there. There might be more steps from there to figure out the exponent value, but that's what we can do. We have to make the base the same, and then we can set the exponents equal to each other. Right, so let's look at some more examples of that because it's a bit odd. So 3 to the exponent x equals 100. So our goal is to get it as close to 100 as possible. We use a scientific calculator. You can use the Desmos calculator. I'm just going to go through what my guesses were. This is legit how I figured this out because I don't know what 3 to the exponent x, what that equals to 100. So I said, okay, well, 3 to the exponent 3 is equal to 27. So I'm not close to 100. I guessed a bigger number. 3 to the exponent 5 equals 243. That's too big. It's more than 100, so I need to make it smaller. 3 to the exponent 4, okay, that's 81. Okay, I'm too small, but I'm closer. So I'm going to guess 3 to the exponent 4.5. That gives me 140.3. I'm too high up. So 3 to the exponent 4.1 equals 90.4. I'm getting closer. 3 to the exponent 4.2 equals 100.9. So that's pretty close. So then we can say, so I say that 3x is equal to approximately, we have a little squiggly equal sign, which is saying that it's an approximation, 3 to the exponent 4.2 instead of 100. So x equals 4.2. Another example, 2 equals 1.0275 to exponent n. So our guess and check, our goal is to get as close to 2 as possible. So we're going to try 1.0275 to exponent 2 equals 1.0558. Okay, so I'm not very close to 2 yet. And I'm just picking random numbers. Well, not random, I'm picking logical numbers for my exponents. So I picked a bigger number for my exponent because I'm not close to 2 yet. So 1.0275 to the exponent 5 is equal to 1.1453. I'm still not close to 2. So I picked a much bigger number. 1.0275 to the exponent 20 equals 1.7204. I'm getting closer, but I'm still fairly far away. So 1.0275 to the exponent 25 is equal to 1.9704. I'm getting closer. 1.0275 to the exponent 26 is equal to 2.0245. So I'll see if I can get a little bit closer. 1.0275 to the exponent 25.5 is equal to 1.9973. So that's fairly close. So then I say in my equation, I replace 2 with 1.0275 to the exponent 25.5 is approximately equal to 1.0275 to the exponent n. So n equals 25.5. And that's how you use the guess and check model when you're trying to find the variable that's in the exponent. Okay, so let's relate how that relates to our compound. So this is, I'm saying finding the time length t in compound interest. This your ILO book says finding n in your guess and check on page 17. So remember, my variable is just slightly different because I do it slightly different, use a slightly different formula. When you have your exam, I'll include both formulas so that you can choose which one works best for you. So the real life context of this is when you want to find out how long you need to invest in order to earn a certain amount. So a company invests $25,000 that will pay at 8.25% compounded monthly. How long will they have to leave the investment for it to double? So breaking the question apart, it says compounded monthly. That means that we're doing a compound interest question. So we can use our compounding A equals P times 1 plus R over N all to the exponent NT formula. We're going to use that formula, and we have to find our values. So we invest $25,000. So our P is 25,000. The investment pays 8.25%. So 8.25 is our rate, which is equal to 0.0825. N is compounded monthly, so N is 12. And it says how long will they have to invest to leave the investment for it to double? So doubling the amount, we think, okay, well, we started with 25,000. So to double that, that's 50,000. So our A is 50,000. And how long is our T? That is what we're trying to find. Now that we have our values, we put them into our formula. So we have 50,000 equals 25,000 times 1 plus 0.0825 over 12, all to the exponent 12 times T. So we simplify what we can. We're going to have 50,000 divided by 25,000 is equal to 1 plus 0.006875, all to the exponent 12T. We continue to simplify what we can. Well, 50,000 divided by 25,000 is 2, which we should expect because we were doubling it. So 2 equals 1.006875 to the exponent 12T. So now we need to use our guess and check. Our goal is to get it as close to 2 as possible. So we say our base is 1.006875, and we're going to guess. I guess 10, and that gives me 1.0709. So not close to 2 at all. So I'm going to pick a much bigger number. So I say 1.006875 to the exponent 20, and now that's 1.1468. I'm a little bit bigger, but nowhere near what I need to be to get close to 2. So I picked a much bigger number. 0.006875 to the exponent 50 gives me 1.4086. Again, I'm getting closer, but I'm not there yet. So I guess a much bigger number. 1.006875 to the exponent 100 equals 1.9841. So I'm getting closer. I'm almost at 2, but see if I can get more precise. Again, this was my process of guessing and checking. They are not the perfect numbers. You pick numbers that make sense to you. You follow your system. You don't have to write this down. You could just use your calculator. So my next guess is 1.006875 to the exponent 110, which is equal to 2.1248. Okay, so let's see if I get closer to 2. 1.006875 to the exponent 105 equals 2.0532. Try one more. 1.006875 to 101 is equal to 1.9977. That's pretty close to 2. So I'm going to say that my base I'm going to replace with my number 2, I'm going to replace with 1.006875 to the exponent 101. And that is approximately equal to 1.006875 to the exponent T, 12T. Okay, so now our base is the same. So that means that we can set our exponents equal. So we have 101 equals 12T. And we can now solve for T by doing 101 divided by 12, which means that T equals 8.4. So therefore, the company needs to invest 8.4 for 8.4 years in order to double their investment. And that's how you do it if you're finding the time length. It is tricky. You have to do the guess and check. It can take some patience, but that are the steps. All right, so now if you want to pause the video and work on some support questions, page 18, questions 1 through 4 is what that should have supported you with. And let's consolidate some of our learning and then do some practice questions. So lesson 8, highlights. So we have to dissect our compound interest problem, which means that compound has to be in the question in the problem in order to use the compound interest formula. And then we must identify what is given and what information you're being asked to find. That's the trickiest part about this, is knowing what you have and what you're looking for. So if we're finding the principal, we need to rearrange the formula using algebra to isolate for P. If we're finding the interest rate, R, we need to use the nth root to isolate for r. If we're finding the time length, we need to use guess and check to force the bases to be the same. Then the exponents can be set as equal in order to isolate for t. So we're always using algebra to isolate for our variable, but we might need to use some different tools to get there. So our success criteria, number 1 was I can identify the given and missing information in the compound interest problems. Our second one was I can use the nth root and guess and check methods to solve problems involving exponents. Hopefully you can do that now, or you can use a little bit more practice. And the third one is I can solve problems when either the interest rate or time length are missing. Those two are the really tricky ones because we have to either use the nth root or we have to use the guess and check model. So that's a little bit harder than just using algebra. So they take a little bit more practice. All right, let's do some practice questions to do in real time, figure out what we are trying to do. So question 1, Jiva is 10 years old. His parents have decided to invest some money for his future so that he will have $15,000 at age 18 when he finishes high school. If the investment can earn 6.6% compounded monthly, how much will his parents need to invest? Okay, so how do I know what I need to do? So first, I say, this question says that we're compounding. So that means that I can use my A equals P times 1 plus R over N to the exponent N T. I have this memorized. You don't have to have it memorized. It's fine if you have to look it up every time. And then so now we're trying to gather what information do we know and what information are we trying to find. So I write down my A, P, R, N, T. Doesn't matter what order you write them in. I just do this order. So then I look at my question. So Geneva is 10 years old and his parents decide to invest money for a future so that he have $15,000. Okay, so $15,000 is how much we want to have at the end. So A is equal to 15,000 at the age 18. So our time is age 18, but we aren't starting at 0. Jiva is 10 years now. So we have 18 take away 10 is equal to 8. So we're going to invest for 8 years. Investment can earn 6.6%. So our rate is 6.6%, which is equal to 0.066 compounded monthly. That means that our N is 12. How much will his parents need to invest? So our principal is what we're looking for. How much do they invest now? Okay, so now I input my values. So A is 1,500 equals to P is what we're looking for. So we leave it as P. 1 plus R is 0.066 divided by 12, which is our N, all to the exponent 12 times 8. Okay, and now we simplify what we can. So 1,500 is equal to P. And then I'm going to use my calculator to do 0.066 divided by 12, and then plus 1 to 1.0055, and that's exact, so I can leave it just like that. And then 12 times 8 is 96. So my exponent is 96. So then again, I do what I can. So I'm going to say, okay, I want to isolate for P. So I'm going to do 15,000 divided by 1.0055 to the exponent 96 is what P is equal to. So then I can do all of that in my calculator. So 15,000 divided by 1.0055 to the exponent 96. Your calculator should do it the order of operations properly. So P equals $8,859.56 is equal to P. So now we have to go back to the question and see, did we answer the question? How much will his parents need to invest? P tells me how much we need to invest. So then I can say his parents need to invest $8,859.56 now. That's how we answer the question. Okay, let's try another one. 2, Everett at age 18 is planning for his future. He has $1,000 and wonders what interest rate, compounded semi-annually, he would need to have $1 million when he retires at 65. Okay, so how do we dive into this question? The question says compounds, so we know that we can use our formula. A equals P times 1 plus R over N, the NT. It probably seems obvious that we can use our formula because that's what we're learning about right now, but eventually we'll have different situations. And so being able to identify what means that we can use this formula is really important, because in life we don't have, it's not like we were just dealing with this situation, so that means that everything afterwards is exactly the same. So we need to use that skill of dissecting the problem to figure out what we know and what we don't know. All right, so then at age 18, so Everett is 18 now, and he wonders how much he'll have at 65. So our time is 65, take away 18. 65 take away 18 is 47. So our time is 47. He has $1,000 to invest now. So our principal is 1,000. And he wonders what interest rate. So what interest rate is what we're looking for? Our rate is what we're looking for. Compounded semi-annually. So semi-annually means 2. That he would need to have $1 million when he retires. So our A is $1 million. Okay, so now we've organized our information. Let's put it into our formula and figure out solve for what we need. So 1 million, 1,000 times 1 plus R over 2, all to the exponent 2 times 47. So then we're going to simplify what we know. So 1 million divided by 1,000 is equal to 1 plus R over 2, and then 47 times 2 is 94. So 1 million divided by 1,000 is 10,000. Sorry, is 1,000, my bad. So that's equal to 1 plus R over 2 to the exponent 94. So now, because R is to the exponent of something, even though it's inside a bracket, it's still the exponent of something, we need to do the nth root, the 94th root of that, in order to cancel off the 94th root, the exponent 94. So we do it to one side, we have to do the other side. So we're going to take the 94th root of 1,000. So you're going to have to put that into your calculator. You have to figure out how your calculator does that. So that gives us 1.07625. Giving yourself 5 decimals is sort of good. We're trying to get exact, as precise as we can. So that equals to 1 plus R over 2. So then we're going to subtract 1 from each side. So 1.07625 take away 1 is equal to 1 plus R over 2 take away 1 to cancel off the 1. So 0.07625 is equal to R over 2. We're going to multiply both sides by 2 to cancel off the 2, isolate for the R. So we do that on our calculator and we end up with 0.15251. I left my value in my calculator, so it might be slightly different than you did. That's fine if it's pretty close. So then R is equal to 0.15251. Okay, we want that into a percentage. So R is going to equal to 15.25%. So Everett needs rate of 15.25%. That's what our question was asking. And there we go. Okay, question 3. Chris and Sydney have $5,000 to invest at 8% compounded quarterly. How long would it take for their investment to grow to $8,000? All right, what do we know and what are we trying to find? Compounded is in the question. So that means we have A equals P times 1 plus R over N, all to the exponent NT. And we're trying A, we need to know, we have our know, our A, P, R. All right, look at our question. Chris and Sydney have $5,000. So that's our principal. That's how much they have right now. 5,000. P equals 5,000. To invest at 8%. Our rate is 8%, which is equal to 0.08. Compounded quarterly, N is equal to 4 if it's quarterly. How long would it take for them to invest, for the investment to grow to 8,000? So 8,000 is our A, how much we want, and how long is our time. That is what we're trying to find. Okay, so now we know our values, and we're going to substitute them into our formula. 8,000 is equal to 5,000 times 1 plus 0.08 over 4, all to the exponent 4 times t. So 8,000 divided by 5,000 is equal to, then we're going to solve inside of our brackets. So 0.08 divided by 4 is 0.02 plus 1. Sorry, I don't know how it just, my screen is being funky. So 1.02 to the exponent of 4t. So we need to do 8,000 divided by 5,000 is equal to 1.6. So we're trying to find 1.02 to the exponent 4, how close we can get to 1.6. So we're going to guess and check. So I'm trying to get, my goal is to get as close as I can to 1.6. So 1.02 to the exponent, I'm going to say 5. We're doing this right now on my calculator. So that's 1.104. Okay, so that's not very close. I mean, it's close, but not super close. So we have 1.02 to the exponent, I'm going to do 10. 1.02 to the exponent 10 is equal to 1.22. Still not close enough. So I'm going to do 1.02 to the exponent 20. 1.02 to the exponent 20 is equal to 1.486. Getting there, but not quite. I'm going to do 1.02 to the exponent 25. 1.02 to the exponent 25 is equal to 1.64. That's pretty close. I'm just going to check 1.02 to the exponent 24, because sometimes you can get closer. So that 1.02 to the exponent 24 is 1.61. So that's what I'm going to use. That's pretty close. So that means I'm going to replace 1.1 with 1.02 to the exponent 24 is equal to 1.02 to the exponent 4t. Now my base is the same. So 24 is equal to 4t. So I can solve for t by dividing both sides by 4. And 6 is equal to t. So then I need to say what my question was. How long would it take for their investment to grow to 8,000? So it would take 6 years for their investment to grow. To 8,000. There we go. We know that we've answered the question. We do fronting your rate. All right. We don't have time to do this last one, but you might have questions where you need to compare situations. So the question I'll talk through, and then you can try it out if you want to. Bethany needs to borrow $2,000. Which loan should she take? Justify your response. So we have A, which is $2,000 for 3 years at 10% compounded semi-annually. And we have B, $2,000 for 3 years at 9.2% compounded quarterly. So you would do these two situations, A and B, and figure out what you have and what you don't have for both situations and find out what your values would be. And then you would compare them. With investments. We assume you want to make money. With when we're borrowing, we assume that we want to have less money. We don't want to have to own as much interest. So you would look at these situations and compare the two and see which one, because Bethany needs to borrow, which one would mean that she wouldn't have to pay as much interest back overall. And that's what you would decide, and you would explain why. All right, as always, if you have any questions, please contact me. This had a couple of extra little quirks in it, so if those things are causing trouble, let me know. You can call me, a message from me at the office at 807-737-1488 or toll free 1-800-667-3703. You can email me at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can message me on Facebook at bslate Wahsa or connect to the YouTube channel where this will be aired or uploaded shortly at bslate Wahsa. I hope you have a lovely day. Which